Hello guys, hope you are doing well. Today I want to present a topic and my topic is on motorcycle dynamic behavior study. I'll use vehicle trajectory and those that are collected using drones. I am Saurabh Barua presenting this topic. So my content covers four parts. Firstly, I will talk about what about motorcycle dynamics and its characteristics at signalized intersection. Then I will discuss on data extraction analysis uh, from data from Sky app. Thirdly, I will discuss on some reviewed paper that I studied regarding this topic. And last but not the least, I will propose some relevant publication, though the section 4, I will try to omit it. Actually, I will focus on the first three topics. So if we look at the first of all, the topic, motorcycle dynamics and its characteristics on signalized intersection, I have divided the topic into 26 components. One of the most uh, relevant topic and exciting, important issue here is lane filtering. We can see that the motorcycle are moving uh, uh, along the stop line and moving in between two vehicle lines. Then there is lane splitting. Lane splitting is both side vehicles, large size vehicles are moving and motorcycle is also moving. The lane splitting and lane filtering is little bit different because in case of filtering, both in between two lanes, two stopped vehicle lanes in the queue at intersection, the motorcycle is moving, that is lane filtering. But lane splitting, in between two slowly moving vehicle queues, is obviously not queue, but slowly moving vehicles, motorcycle is moving in between that two uh, lanes. And there is queue jumping. Motorcycle often has the property that they try to move somehow at the front of the queue. Then there is a dynamic discipline issue related to motorcycle. There are lateral waving. We can see motorcycle try to sneak through the gaps. And we have some dynamic lane selection, that motorcycle sometimes change their lane and select their lane very randomly and quickly, and there is a quick dynamic effect. We can see motorcycle try to move through the center line, which is also known as number 7. We can see there is center line riding. Sometimes this type of vehicle tries to move through the shoulder, and which is known as shoulder riding. We can also see multiple motorcycle occupy in one lane. It is very common. There is stagger following, that is cycles do not actually follow uh, bumper to bumper, rather than they are following some vehicle. The following vehicle in staggering manner. There is also some platooning effect we can see, and along with that behavior, we can see staggered following, which I have already mentioned, motorcycle platooning and stop line encroachment. We can see that the motorcycle sometimes just over the stop line, they stand still just over the stop line. Crosswalk occupancy, we can see this tendency in the motorcycle, that is in the 18 number. There is rapid startup when the signal is green at the intersection. We can see that the motorcycle take startup very rapidly. Aggressive overtaking is another property of it. Beside this, we can see that the acceleration gap ring exploitation, motorcycle try to exploit the gap and try to make a acceleration to occupy the gap. Edge riding motorcycles in lot of cases we can see that the motorcyclists try to move through the edge of the road. Multiple motorcycle occupy one lane. We have already discussed lane sharing is common for motorcycles since they have least width, say they occupy multiple lanes. Turning from non-designated lane is also common for motorcycle. Quick maneuvering, obviously because of their physical properties, those motorcycle can move, have the quick maneuvering properties. Car or heavy vehicle cannot do that, or large cycle vehicle cannot do that. Conflict avoidance maneuvering is also common. Early merging, since motorcycles try to do rapid startup, they also do early merging. Late merging can also be possible for also not only possible, it often happens. It's one of the motorcycle behavior. Rolling stop is another thing. We can see that in the stop line, vehicles do quick maneuver and it is often observed. So these are the all properties we can see at signalized intersection, and is very common in motorcycle dynamics, which actually make motorcycle distinct from other type of vehicles. So we need to have study motorcycles at signalized intersection. There's actually a number of papers on lane filtering and lane splitting behavior. In the next topic, we extracted data from sky. Actually, if I want to show the data we have studied, we have firstly we have I want to show the data from sky, what type of information we actually gathered. Just once. These are the data that we received from data from sky. We have track type, entry gate, exit gate time, entry gate, exit gate time, travel distance, average speed, trajectory x, y speed, tangential acceleration, lateral acceleration, and time step for every vehicle in 1/30 second, and these are for every vehicle, but these values are given here in the row wise for every vehicle. We can see this is the raw data we extracted from data from Sky software, and using the Python coding, if I look at the formatted code, using the Python coding, the row data are converted to the column data, and also heading are adjusted for formatable version. We can see that we have track, vehicle type, entry gate, entry time, exit gate, exit time. I have travel distance, average speed x, y speed, then xy is the position of vehicle in the road, tangential acceleration, lateral acceleration, and time step for all these vehicle. Using the Python code, here is the Python code. I converted the raw data to the usable format. So I have two Excel form. One I get from the data from Sky, then using Python, I converted it into the usable format, and also do Python calculation. And this is the Python code to analyze the formatted data. Firstly, load and clean the data, then heading align for kinematic frame, then per track behavior metrics, lateral and for longitudinal motorcycle behavior. I adjusted it. In the third step, in the fourth step, I try to find out the information regarding gap acceptance, which use time bin nearest neighbor search. Then I use intersection and queue behavior. Sixthly, I wrote the Excel workbook. And in the seventh part, I plot all relevant analyzed data, and this is the code. So this code has 7 parts actually, these all together here. And if we look at the Excel output, we can see in the Excel output of the result, we have metric of average speed, maximum speed, mean acceleration, mean deceleration, startup reaction. Lateral speed means position, filtering time, filtering distance. For motorcycles, mean standard deviation, car mean standard deviation, all are given here. This is the first Excel sheet. In the second Excel sheet, we have motorcycle track metrics. Here we have ID, type, entry gate, exit gate, duration, travel distance, average speed, max standard deviation speed, acceleration, max mean. Similar for deceleration, we have reaction time, lateral speed mean, lateral speed standard deviation mean, and we have position, lateral position of vehicle. Here lane change frequency also recorded, calculated actually, and percent time of the center is also calculated. Filtering time is also calculated. Filtering distance and filtering speed is also calculated here. In the third Excel sheet, we can see that we have nearest neighbor gaps. In the gap acceptance summary, we have nearest neighbor gaps, longitudinal gap, lateral gap, mean, max, mean, median value, 85th and 15th percentile, and standard deviation are given. For gap raw information, we have for every vehicle, we have gap distance, longitudinal, lateral distance, and neighbor type is also given. Neighbor can be motorcycle. Okay. In the fourth Excel sheet, we can see that the Q front share percentage is given for car, heavy vehicle, medium, motorcycle is given. I can also see the track ID, observation, and percent time ahead of any vehicle. We can also see. In the next slide, next Excel sheet, we can see that the motorcycle lane sharing distribution in terms of percent of observation is given. In the 5C slide, we can see the motorcycle headway summary information. Those include concurrent motorcycle per entry, concurrent motorcycle per entry for max, mean, headway between vehicle for mean and median is also we can see. And motorcycle headway by track, we can see for every motorcycle the headway track, entry gate, entry time, and headway is shown here. And some assumption notes are given for filtering. Lateral speed, if speed is greater than 0.15 meter per second, while speed is less than 20 kilometer per hour, moving side in the slow, we can consider it filtering. For queue or stop, instantaneous speed is less than 5 kilometer per hour, it is considered as queued or stop. Similarly, for gap acceptance, nearest neighbor vehicle position within 0.5 second time bins is decomposed to longitudinal or lateral frame. Similarly, for startup reaction, time from leaving a stop state less than 5 km per hour to reach 50% of track average speed is considered a startup reaction time. And these all about the Excel analysis. If we look at the presentation slide, we also obtained some graph. In the first graph, there is longitudinal behavior for motorcycle versus car, we can see that the mean average speed of motorcycle is 43.5 kilometer per hour, but car it is 28.8 kilometer per hour. And we can also see that the number of motorcycle and car observed uh, during the observation period. In the second right top graph, we can see that the longitudinal behavior for motorcycle acceleration, deceleration. We can see that the mean acceleration for acceleration is 1.12 meter per second square. For deceleration is minus 1.89 meter per second. And in the bottom left, we can see that the lateral behavior that covers lateral position distribution of motorcycle and car. And standard deviation for motorcycle is 5.09, standard deviation for car is 4.89. If we look at the bottom right, the lateral behavior, lateral speed versus lateral acceleration graph for motorcycle track, and its Pearson R is 0.86. In the next slide, we can see that the lateral behavior of motorcycle lane filtering and weaving frequency, we found the mean is 2.51 per 100 meter. And this is shown the lateral direction reveals per 100 meter travel, a number of motorcycle. It's been together for motorcycle lane filtering. You can see it in the top left side graph. In the top right side, we can see that the intersection behavior headway between consecutive motorcycle. We can see that the headway in entry gate value shown in less than 30 seconds. We can see that the mean value is 1.02 second. Also in the bottom left side graph, we can see that the intersection behavior share of time each vehicle type occupies by front of queue position. We can see that the motorcycle occupies almost 47%, car occupies 42.6% of all vehicle. And in the bottom right side graph, we can see, just going back, we can see that the motorcycle sharing same 1 meter lateral band. We can see that the almost 69% case, 69.3% case, it has 1 meter lateral band because motorcycle are sharing same space. Motorcycle sharing 2 meter band is only 16.5 and others are very low. And these are the all 8 graphical representation I obtained from the using Python code. Now comes to the briefing of review paper. I reviewed almost 3 paper. First one is lane filtering behavior. It is paper research article paper in published in a Scopus Index journal. It's a PhD thesis. This first one, the from Raksa 2022, this research is done in Thailand, in a Thai city. And it used the onboard measurement device, used radar, Hall effect sensor, and GPS to test motorcycle, applied multivariate regression, and it used 30 participants. The study investigates factors related to the lateral clearance of motorcycle lane filtering in a Thai city. Filtering speed, vehicle side, lateral vehicle type condition, riding frequency are studied here. In the next paper is a study from India. It used calibration of Sumo for Indian heterogeneous traffic condition. It's a conference paper from book chapter. It used sensitivity analysis, one-way ANOVA, and genetic algorithm to calibrate Sumo simulator and compare with vSim. Use MAPE for error calculation. It developed a methodology to calibrate Sumo software for motorcycle, especially for lane less heterogeneous traffic condition in case of India. And data used here from Chennai city. There is a sublane model documentation in Sumo. I also put it here. It has sublane model logic, detail about lateral resolution, also discussed on, if we look at, also discussed on some parameter like LC sublane, mean gaplet which influence the simulation. The documentation explain sublane model in Sumo. Uh, it includes the granular lateral movement simulation, also model the phenomena like motorcycle driving in parallel, lane splitting, and virtual lane formation. These information is given. Actually, just getting off from the presentation. If we click on the paper, firstly, that I discussed, it is published in the Journal of Advanced Transportation. We can see that this paper use test driving, and this test driving is conducted in a signalized intersection in a city in North Thailand. And this study use some onboard measurement device like LiDAR, Hall device. We can see the devices, Hall effect sensors, also camera to detect the vehicle lane filtering behavior. The data were collected from Khon Kaen city. And we can see that the layout of the study and the results you can see, and they make some discussion regarding the vehicle, especially motorcycle behavior in signalized queue. They discuss the topic. If we look at the discussion of the topic, especially in case of, say, if a motorcycle is running inside of a stock vehicle, it will provide small lateral space. If the motorcycle is running in a comparatively faster vehicle, it will keep a larger lateral gap. And experience is also factor. Driver's experience is also factor. Motorcycle try to avoid large size truck type vehicle, and it keeps larger lateral clearance. These are discussed here. In the second paper, which actually a conference paper published in stringent nature proceeding, it calibrates Sumo from Indian heterogeneous traffic condition in Chennai. They also consider real geometric and get traffic data from Chennai intersection in Chennai, but it first modeled using vSIM, then compared the vSIM study result with the Sumo and calibrate the parameters of Sumo to match as close as the vSIM result using genetic algorithm, and the calibration in terms of parameter adjustment. It adjusts, for example, driver imperfection parameter, minimum gap at junction condition, speed deviation, desired acceleration at 0 kilometer and desired acceleration at 60 kilometer. It is studied. These parameters, firstly, the ANOVA value identify which parameters are important. Then what it did, it then choose the values and identify how close the value with the vSIM result. And this choosing selection of parameters are actually adjusted using genetic algorithm with trial and error. Genetic algorithm is a method to optimize, find the optimal value of these 13 parameters. It calibrates all these 13 parameters. And this is the study, and we can see that the said traffic behavior in the sumo model here. In the third, actually, which is a documentation of sumo, we can see that the sublane model and what I discuss about the what is sublane model in sumo, lateral resolution, and different parameters like LC pushy, some parameters like car following, lane following, LC sublane, LC pushy, LC assertive, LC lane change impatience, LC time intolerance, toll patience, LC late alignment, LC max speed, late standing, LC max speed, late factor. Those are discussed here. We can see that the lane change model, simple lane change model, how to do this, and vehicle parameters are discussed. These are the documentation of sumo and what values actually it takes in the sumo model for lateral resolution. In the lateral resolution, actually what we can do, we can subdivide any lane into multiple subsections so that we can do more granular analysis. Actually, it takes more time compared to regular lane-based traffic modeling. So we have to select the lateral resolution based on the vehicle size, especially motorcycle size. If there are a significant number of motorcycle or bicycle, we have to consider while simulation run. So this is all about my presentation. Hopefully you enjoy it. I'll provide the detail of this study and code. I will provide the link in GitHub. You can see the link there.